So today we are going to discuss, we're going to resume from the last class. In the last class we have seen why we need a framework to be developed for maintaining our test cases, what are the benefits that we used to get, and how we can basically start developing a framework. So in that we have seen that we are creating two Maven projects. The concept of Maven multi-module project we have seen in Eclipse. We created a parent project test automation. Within that we have created two modules, automation framework and automation project. The automation framework contains the code which are common, which is type of utility which can be used again and again in multiple test cases. Okay, and the data provider related stuff, we're going to put them over there. We're going to put the logic to read the file and database read write operations, screenshot utilities, etc. In the automation project, we are going to uh, create only and only test cases or test case logic. We're going to write the logic for the test case. It will have only @test annotation, and it can have annotations like at before, before class, before method, after class, and after method. So these are the things which we have seen yesterday, and we have created a dummy project as well. We have started creating the project. So if we go and look into that project, what are the two things that we have found out to be part of the framework are, first one is the driver creation. It used to be happening in all the Java classes that we have in the project. So the driver creation part needs to be outside the test case, and as it is called again and again by all the classes, all the test cases or all the classes, we can put the driver creation logic in the framework. Similarly, the environment setup like setting the Gecko driver, Chrome driver, or if you have some IE driver, all these things they need a driver to be set up. So that driver setup part we can do only once, and that can be done in the framework. So let's see how we can create a driver and how we can get the driver from the framework within the automation project. Now, if you look at this, we have two projects, the framework and the automation project. Now, this framework is going to have the logic to create, and create the web driver. So this logic needs to be part of the framework, and the automation project is going to call the framework for web driver. So now these are the two things which we are going to see how we can do that. Now somehow this automation project, it depends on the automation framework. So we're going to see how this dependency we can manage. So let's go ahead and start coding. First of all, we need to create a web driver. So let's save everything and let's go to the framework project. In the automation framework, we can expand and we can see this containing a default class. Okay, the default packages are created which we may not need, so let's delete them. Fine, that deleted. Now we're going to write the logic in the main method. So let's create a new Java class and let's give it a package name form dot. So the name is driver manager. Okay, name of the class is driver manager. So this class doesn't need a main method to be there because we'll have some of the methods with meaningful name. So right now we want to create a driver, or we can have a method whose name is going to be get driver. So this method is responsible for returning us a web driver. So this method cannot be private because this method needs to be called from a separate project. So let's make this method as public, and it doesn't return void, it returns web driver. So let's import web driver from Selenium, public web driver get driver, and let's remove the comments. Let's create a driver reference, driver equals, let's keep it null for some time, and we can return the driver. At the end here we are going to put the logic for driver creation, right? Somebody may be trying to create a Firefox driver, somebody may be needing a Chrome driver or Internet Explorer driver. So we need to pass the type of the driver over here. So There can be three web drivers, three browsers which are supported. So we can give support for two drivers right now. Say for example, public static final string browser underscore Firefox equals to Firefox. Similarly, we can have browser underscore Chrome, and we can have the value as Chrome. Now we have two constants which are created. So over here we are going to accept a string browser name. So the user can pass a browser name apart like within these two values, Firefox or Chrome. If the user passes something else, if the user doesn't pass, if the browser name that the user has passed dot equals browser underscore Chrome, then we are going to create a Chrome driver, right? So how can we do that? We are going to create the driver equals to new Chrome driver. And if the user is not passing that, if the user is passing the browser name dot equals browser underscore Firefox, then we are going to create a Firefox driver. Else if, perfect. And if something else the user is passing, we are going to throw some error. So we are going to throw new automation framework exception. So this exception is never defined. We are going to create a custom exception, and we are going to pass the message as browser, name the browser that the user has passed, plus not yet supported. So the user is passing some value which is not yet supported, and at the end we are going to return the driver. So let's first create this custom exception. We can create this exception in the framework, create class exception, and this exception is going to extend the java.lang.exception. If you remember the classes when we discussed about creating custom exceptions, this is what we have done, and we can use the constructors from superclass. Let's click on finish, and this is going to have a generated serial version ID. Save, close this one, and it needs the method to throws this exception. Now this is ready. So what is going to happen, this driver manager is present within the framework. So what the automation project classes are going to do, they are going to call driver manager dot get driver, and they will pass either Firefox or Chrome. So when they're passing Firefox, this condition, else if condition, is evaluated to true. So we are going to create a new Firefox driver, and we are going to return that driver. If they're passing Chrome, this is executed, a new Chrome driver is created, and that driver reference is returned. So what we are going to do, before creating any Chrome driver or Firefox driver, we need to initialize the system properties. To initialize the system properties, what we can do, we can create a static block. Within that we can set the system properties, like setting the Gecko driver or the Chrome driver. So let's copy these two values and let's paste them over here. So this static block, what happens, whenever the object is created for the first time, the driver manager's object is created, at that point of time it is going to set these variables. So it is not going to be called again and again, and the drivers we are going to get from here. Now we have written the logic to create the driver, but we have not yet written how we can get that driver by calling this method. Now this method or this class is present within the framework, but we want to have the access to the class which is created within this framework. We want to have the access from automation project. So how can we do that? So let's try to write the code and let's try to get the access. So here we're creating the driver directly. So now we don't need these two lines of code. We don't need to initialize because they're already initialized. So
Sir,
yes,
why we are using static final keyword with driver?
that is the way we used to create the constant. Static means it can be, this variable can be accessed without creating object of driver manager, and final means this variable's value is not going to be changed anymore, okay, throughout the execution of the program. And public is to give access to these variables even outside the class. Okay, so if you want to call this method, then we may need to create the object of driver manager. But if you want to restrict that, if you want to call this method directly, you can make this as public static web driver return, and the method name is going to be get driver. So let's save it and let's try to call this get driver method using the driver manager from the automation project. So here what we are going to do, we're going to create the web driver this way, driver equals to driver manager. See, the driver manager is not available. It is available from java.sql package, but we are not interested in that. So let's do one thing. This is not directly available. To make it available, these two projects, they need to define a dependency. The automation framework dependencies should be injected in automation project. That means the automation project is going to be dependent on automation framework. So what is going to happen? We are going to put the dependency of automation framework within automation projects pom.xml. To make that possible, we are going to open both the pom.xml files and we are going to see what are the dependency information that we can have in the pom.xml file. So first we are opening the automation framework pom.xml. Here we can go to the top and we can see there are lots of information, but we are interested only in the group artifact and version of the project. Because this group artifact and version, it defines the project. We are going to copy this group artifact and version GAV information of the framework. Inside we are going to copy this. That means this framework is going to be copied within this automation project. So how do we add the dependencies? To add the dependencies, we go into the dependencies section. Over here you can see some other dependencies already there. So let's copy and paste it over here. 1 second, we'll need the dependencies tag. So within dependency we have put. So this dependency is basically being copied com.mentorstudies.automation framework 001 snapshot. This represents another Java project. This is the Java project framework. So all the code that are available over there are going to be copied as a dependency into automation project, because in automation project we have specified the dependency on automation framework. So these two are not needed. So let's see. Let's try to build and run the code. So whenever we try to build the project, we should not build them from here, from the automation framework or from the project. We should build them from the parent project, because this parent project contains both the projects. So when we say parent project build, it is going to build both the projects. So in parent project pom.xml, we can find the information about the two projects and the hierarchy, how they are going to be built. So you can see the modules. First it is going to build the first module, that is automation framework, then the automation project module. To build this project, we are going to use a Maven command. So how we are going to build? In the parent project, test automation, right click on the pom.xml, go to run as, find the Maven build, click on that. So in the Maven build, for the first time it is going to ask for the goals. The goal is something which defines how the project is going to be built. Are we going to build the project? Are we going to clean the project? Or are we going to create the jar file? Are we going to run some code? So all these information are provided within the goals. We are going to use the clean goal then we are going to package, and we are going to install. So each of them has a specific meaning. So clean means it cleans the .class files or some temporary files which are created earlier. Package means it is going to compile the Java files into respective .class files and convert the project into a jar file or war file, whichever is needed. After creating that jar file, it is going to install the file if we give the command install. If we give the goal install, what it is going to do, it is going to use the group artifact and version information and install the jar file in your local system. So right now we have given clean, package and install command. So let's run this and let's look at the console. This is the console. So once we run this, we'll get this console. It is building the project for the first time. If you can see, it is downloading some of the jar files from internet. So these are the jar files which are needed for compiling and building your project. So it will take some time initially, but later on it's going to work perfectly fine. Now at the end you can see test automation is the parent project, which is success. It has two projects, automation framework that is successful and automation project that is also successful. Now we can go back into our automation project, right click and refresh. Now we are going to get this automation project as a dependency in the automation project. Automation framework as a dependency or as a jar file or as like it is packaged and it is copied into automation project. So we can directly use the class or the driver manager of automation framework inside our project, automation project. To see how it is imported, you can expand the Maven dependencies and you can go to the bottom over there. You will see there is this thing. Okay, at the bottom it has a reference to automation framework because you have given the dependency information in the pom.xml. So let's do one thing. Let's go back to our test case, that is Selenium test case. Over here we tried to import the driver manager, but we faced some issue. So let's try to import that again. This is the driver manager. We are going to call driver manager dot get driver. So it should work now. So let's try and run the code. So driver equals to driver manager. When I see use control space, I'll get some option. From that, I'm going to use the option from the framework, com.mentorstudies.framework. Driver manager dot get driver. And while creating a driver, we must specify the name of the browser. We can write Firefox, or we may face some issues while writing this text because we may make some typing mistake. For that reason, we have created some of the constants. So we can use those constants, driver manager dot browser underscore Chrome or browser underscore Firefox. But while calling this driver creation, because some people might pass some other string value, it may throw some error. To handle that error, we must keep it inside a try catch block. So that error is that exception is thrown as a custom exception and it needs to be handled over here. So we can use a try catch block to handle the exception, and we can say when the exception comes, we can fail assert dot fail, and we can pass the error message something went wrong while creating driver, and I can let the exception go ahead. Let's save the code. So this is what we have done. Earlier we used to create the driver using the new Chrome driver option, but this has to be repeated again and again in every class. But now we are not going to do that. We are putting that as part of the framework, but still we have a small dependency. We are still calling the framework's method get driver, but we are not creating the driver directly. The framework is creating it for us. So let's try to run the code and let's see if it runs perfectly fine for us. Then we'll go ahead and make certain things even more simpler and part of the framework. So let's run the code. To run the code, what we are going to do, we are going to right click in the class, run as Java test-ng test. So you can see a new Chrome driver has opened and it is running fine as we have expected in the last example. It is asserting the Google home pages title bar as well as the Google images title bar, and it is very simple and it is passing both the time. You can see both the test cases have passed with green color mark. Now the problem is still there. We tried to externalize the creation of the driver and we don't want the driver creation to be headache of the test case creation classes. So this before class is always containing the same logic. It is creating the trigger. So we can have another Selenium test example too. In that we can have some more test methods, but again we are going to have write this before class. So this is creating the problem. So what can we do? How can we remove that headache? In Java inheritance, if you remember the concept, in inheritance, a parent class has some of the behavior which is inherited to the child class. So what we can do basically is, we can have this before class in a class, and this class Selenium test example is going to extend, it is going to extend driver or like test. We can create another class as test manager. This class can be created by us and this class is going to contain the before class. So we can have the before class being created within this class. How to do that? Let's create the class, but this class needs to be created within the framework. So let's go to the framework within source main Java. Let's create this class. Within this framework we are going to have @before class. And this before class is going to be, this entire code is going to be cut and pasted within this. So we'll have the before class, we don't have to set up anything, and we'll create the driver. So this driver creation is also going to be part of the before class. Let's cut and paste that in the test manager. We need to make it public or we can keep it as default, and the driver instance is now created. All we need to do is we need to extend this test manager so that this default part is available in its child class, and this before class is also available in the child classes. Now it is trying to access the driver, but that is not directly available as it's not visible. So we need to make it public. The problem being, this test manager is part of the framework, that's a separate project. It has a different packaging structure, different package. The default ones are available. If you remove the public, this variable becomes default, and the default is available just within the same package for inheritance. This is not visible over there and it is not inherited as well, so we can make it public and we can save it. Now this test manager is going to be like inheriting this property to its child. So in Selenium test example, we can directly access the driver, right? So this is it. So let's try to run or like build the project again, and we may go on, Sana.
So a default XFIR is only within a class?
Not in the class. It is what we call as a package default. So this variable is going to be available within the package. So what is the package name? This is the package com.mentorstudies.framework. So all other classes who are extending or were available within the same package can have access to this variable. If you are putting the class in a different package and trying to access it with the default package, it's not possible. So you need to have public to make it available for others. Okay, so you can see this is the package name, and it is having a WebDriver driver, and this C is having a different package name, right? This package name and this package name, they are different. So you cannot access the variable directly. Okay. As we have taken the driver reference in the superclass, we have created the driver reference, we have initialized it, and at the end again we are doing the same thing, and in every other Selenium classes, this is one of the Selenium test example. We can have multiple such classes, and in all the classes we are going to have such @test annotation and after class as well. So this after class is repeated, so we don't want this. So let's remove this and put this in our framework. In the test manager, we can have the after class as well. This after class will also be inherited to its child, that is Selenium test example, and our code has become even smaller. Right? We are just concentrating on the test case, the test case logic. We are not even creating the driver. Driver is created by someone else, but we are inheriting the behavior. And you can see just one thing we need to maintain, that's what we call the test manager. That class we need to import from the, we need to extend from the superclass. So we have made certain changes in the framework, and whenever there is a change in the framework, it's better to build the project, the parent project. This is the parent project. It's better to build the parent project so that everything is built automatically. To build the parent project, we need to right click, go to run as, and click on Maven Build, the first one. And if you remember the last time when we have run this, we have given certain commands, certain goals, and this time those goals are going to be executed as well. We don't have to specify any more goals, and you can see the test like these three builds have been successfully executed, and our project is now available at the automation project. This automation framework is now copied, or is copied as a dependency into automation project now. So all we need to do is we need to refresh this, and we need to run the test case. So let's try and run the test case. Now you can see there is no change, and the driver is ready, and you can see the testing is happening very fine. The test case needs to pass. Yes, it passed. So this is how we're approaching for the framework. We'll keep writing more code, and we'll see the pain areas, and we'll move them into the framework, so that the automation developer is going to work only, it's going to focus only and only on the logic, not on the framework part. So the code is going to be very simple, very easy to write, and he can write the code in a faster way. It's easy to maintain as well. So anyone having any doubt?